Had Christopher Columbus been so lucky, he'd have sent a robot ahead before setting out for the New World. In the late 1990s, this Russian robot should be exploring the new world of Mars, reconnoitering for a manned landing. And this American robot could be gathering Martian samples for dispatch to Earth. The vehicles are planned as international ventures. They'll be designed to deploy miniature robotic explorers. This American smart rover will have a mind of its own, the ability to select packages of soil and rock for analysis back home. With the courier aligning for blastoff, the rover will trundle away to seek another consignment. For the courier, a quick ascent through the wispy Martian atmosphere and orbital rendezvous. Untouched by human hand, the transfer of a package from Mars for shipment to Earth. Run by robots, the consummate cosmic courier. But robots are nothing new, especially for the Soviets. This early rover was built to explore the moon. Under test here, it was to be remotely controlled from Earth, a development spurred by the failure of the Soviets' manned program. Lunokhod, as it was called, worked successfully on the moon in the 1970s. A substantial vehicle, its main task was to return television pictures. Subsequent Soviet robots returned lunar samples. They were shipped to Earth in a craft that looked like a mini Kremlin. The two Voyager probes launched by the Americans in 1977 have been the most successful robots. Powered by nuclear rather than solar energy in the dark outer reaches, they've unveiled the giant planets like Saturn. A super Voyager will return to Saturn early next century. Its name, Cassini, a Euro-American enterprise. Cassini will drop a lander on the Saturnian moon Titan. When Voyager passed by, Titan was shrouded in haze. By soft landing a robot, Cassini should reveal the surface. Titan is a planet-sized moon, and with an atmosphere rich in nitrogen, it's like Earth in deep freeze. That's the fascination. As Cassini departs Titan, it'll slot into orbit around Saturn, a robotic eye that'll have the planet under permanent surveillance. This is a robot with a sting. A scheme by America and Europe, as yet unscheduled, to land on a comet. Not with an astronaut or a robot, they would never survive, but with a hefty reinforced dart, jam-packed with sensors. Like a syringe taking a blood sample, the dart will probe the nature of this dusty cosmic snowball. Then, via the mothercraft, data will be beamed to analysts on Earth. The chunky robot, Galileo, has been on its way since 1989. The American shuttle which launched it hadn't the power for a direct shot. So to gather momentum, Galileo had to swing once round Venus and twice round Earth. The objective was Jupiter, a journey that will have taken this mission all of 6 years. Once there, in 1995, Galileo will go into permanent orbit, and it'll deploy a probe. A kamikaze plunge towards the planet. A single chance. Data must be gathered and zipped to Galileo. Within minutes, the probe will be consumed in the crushing Jovian atmosphere. Less dramatic, but equally significant, is the activity of robots nearer home. Earth is girdled by thousands of them in the shape of artificial satellites. Eyes in the sky that keep the planet under constant observation. Indeed, 3 satellites in geostationary orbit over the equator can cover the globe. A 4th is just a bonus. Satellites work in many ways for telecommunication, navigation, espionage. They also tell us about our planet. Here, for instance, is Earth's topography. Red and black for the highest regions, light green for the lowest. And this is the planet in relief, with shading to emphasize uplands. These are differing terrains, composite data from satellite. Soil types. Greenland beneath ice with no soil shows black. The ecosphere, ice cover in red and deserts in dark blue and purple. And the world's conurbations, illuminated at night. In green, the concentrations of life in the oceans. Here, the distribution of plankton, the microorganism vital to marine ecosystems. And this time-lapse of the Gulf Stream, the great northwesterly drift of the Atlantic Ocean. Of all satellite images, this contour picture of the seabed is among the best. It was compiled through the American orbiter CSAT by using radar altimeter readings of the ocean's surface. So what we're looking at isn't the ocean floor, but the surface of the sea corresponding to the ocean bottom. In other words, the sea isn't flat. It has humps and hollows that match the ridges and trenches of the seabed. With green as vegetation, this is time-lapse of the growing seasons. Summer in the north. Summer in the south. Again in the north. Global or continental, satellites allow no secrets. Over 52 weeks in South America, they show the picture from the Amazon to the Andes. Voyager did the same from Jupiter to Neptune. Its next encounter with a star will be 40,000 years hence. A robotic rendezvous we'll never share.